Okay, so I'm going to rearrange these terms on number 29. I'm going to rearrange them to look like this. Sine x, cosecant x, cosine x, secant x, tan x. Now, there's nothing wrong with rearranging the terms because they're all it's all multiplication. It's no different than if I said 2 times 3 or 3 times 2. But there is a reason why I've done this. What can you replace cosecant with?
1 over sine.
1 over sine. And what can we replace secant with?
1 over cosine.
Anything cancel out?
The sines and the cosines.
And
The cosine.
and the cosines, exactly. What in the world? Why is it drawing a dot? I didn't want a dot. Oh, what is that doing? Okay, I've got to, if I can get rid of that. That's not what I wanted. I wanted to draw. There we go. Those cancel out, leaving me just with tangent x.
1 times tan x.
Yep, that's it. So it's just tangent x for that, for question 29. Okay, so what was next on my list?
35.
35. Now, with this one, do you notice that both of these have a sine x in the numerator? So the trick I'm going to use here is it's actually a greatest common factor. So I'm going to pull out a sine x, which would leave 1 over cotangent squared x minus 1 over cosine squared x. Do you see that, how I did that?
Yeah.
Okay. All right, next. Oops. Slide this over. What can I replace 1 over cotangent squared x with?
Tan.
That's tan squared, right? So we still have the good old sine squared, or sine x on the outside. Oops, sine x. Then we've got tangent squared x minus, what are we going to replace this with?
Secant squared.
Secant squared. Yep, secant squared x. Okay. So let's see here. If you look at your Pythagorean identities notes, what could you replace tangent squared with? On the Pythagorean identities, is there a tangent squared in the bunch?
Secant squared minus 1.
Secant squared minus 1? Is that what you said?
Secant squared x minus 1.
Yep. Okay.
Oh,
You see how those two cancel out?
yeah.
So we have -1 times sine x, which is just written as negative sine x.
Okay.
Does that make sense? Okay, so that was numbers 29. And what was that one again?
35.
It was 35. Okay. Got to know what to title the video. All right. And what was next?
39.
39. Oh, it must be a different page.
I see how, like, how you do it. I just don't know how to start anymore.
Okay.
It's always like a different way.
This one is a lot easier than 43 and 45 because there's nothing weird going on here. We have a squared term, which is based on cosine. We have a linear term, which is based on cosine. Therefore, this one is it's a very straightforward question. It's not like 43 and 45. They were kind of trying to trick me by, making me do some replacements. But here, 39 is just really very straightforward factoring. So, what would you get to multiply together to give you cosine squared?
Cosine x and then cosine x on the other side.
Yep, cosine x. You're exactly right. Now we've got a plus 1 at the end, which means either both of the signs are going to be positive or they're both going to be negative. And there's not a whole lot of... What'd you say?
Positive.
They're both positive. You are correct. This would also be verified because if you multiply the outsides and insides together and then added them up, you would get 2 cosine x for the middle term. I would take that as an answer, or I would take cosine x plus 1 quantity squared. Either one of those.
And then,
So that was nothing near as hard as 43 and 45.
yeah.
Okay, so that one was 39. Okay, then what?
47.
Okay, 47. Okay. Now that you've done 49, remember how we did 49? We replaced the top, sine squared x, with 1 minus cosine squared. Then we saw a difference of perfect squares that we could substitute, and then we looked for a term to cancel out. Now let's go back to 47. What do you notice on the numerator there? What can you do to the numerator? What?
You can factor it into sine on both sides.
Yep, but it'd be 1 minus sine x and 1 plus sine x. All over 1 plus sine x.
The 1 plus sine x we cancel out.
You got it.
It'd be 1 minus sine x.
Perfect. So, 49 was more difficult. 47 was easier. I mean, once you see how 49 works, then that makes 47 a lot easier.
Once I saw how it works, then it's
Yeah,
a lot easier.
it is. It is a lot easier once you've seen it. And that was 47. Okay. Are there any others?
Nope.
Okay. All righty.
Thank you.
I'm not sure if 43 and 45 are in one of my other videos, but I'm going to just talk about them right here since I've got them up on screen. 43, they were trying the giveaway, or the thing that you should be looking for is the linear term. Okay, so that linear term, oh, I didn't hit the scribble button, no wonder. The linear term is cosine x, so that meant I was going to look at the quadratic term and replace it. If you go back to your Pythagorean identity and you solve it for sine squared, you would get 1 minus cosine squared. So you can see on the next line, what I did was I kind of pushed this term over here so that it would be in the middle, because that's my linear term. And here's my minus 2 and my sine squared x. But I replaced the sine squared, obviously, with 1 minus cosine squared. Then at the end, you're going to see my plus 1. Now, I knew that I had to distribute the negative 2, and negative 2 times 1 is negative 2. That's why I put that down here, because I knew that was a like term. That was a like term to the one at the end. And when you add those together, you get negative 1. And when you distribute the negative 2 to the next one, that's where you get the positive 2 cosine squared. So you can see I transferred the middle term, which is the linear term there. So right here, what I'm circling is the quadratic, right? Got the quadratic term, the linear term, and the constant. And then we went ahead and factored it. What would multiply together to give us 2 cosine squared to be 2 cosine x and 1 cosine x. And then factors of 1 or of negative 1. Obviously positive 1 and negative 1, but it's important that you note where you're going to put them so that your insides and your outsides end up giving you positive cosine x. Positive cosine x. So that's what we ended up with as our final answer on that one. On 45, they tried to trick me a little bit. We didn't fall for it. So they tried to disguise the middle term and the constant at the end. So the purple box here, minus 4 cotangent, so I separated that into minus 4 over 1 times 1 over cotangent x. And minus 4 over 1 times, then I looked at this, minus the 1 over cotangent x, and said, hey, I'll replace that with just tangent x. So now that middle term is now minus 4 tangent x. But at the end here, I've got sine x times cosecant x. And so you'll notice that I wrote that right here. Sine x, cosecant x can be changed into 1 over sine x. Those obviously are going to cancel out, giving you a plus 1 at the end. So the plus 1 is right there at the end. So we had the original 4 tan squared x. Then we found the minus 4 tan x. And then we found the plus 1 at the end. And I show you how I factor that in 2 factors. 2 tan x minus 1 for both. Which would be, that's one way to write it, and I would take that. Or 2 tan x minus 1 quantity squared, which is the orange box at the bottom. So just thought I'd throw those into the video. And you have a great evening as you work on other homework.